what I want to do today is hopefully finish up the GameBoy Header Extractor tool that I started writing a few days ago. Uh, who knew it would take that long? I mean, to no surprise to anyone, because I'm quite new to C. I don't really know what I'm doing. I'm very new to Windows programming as well, so I don't know what I'm doing there either. And I'm completely new to GameBoy programming as well, which is, you know, so a lot of new things, a lot of stuff to learn. So it all takes a bit longer. And obviously, while I try to talk, into the camera and explain what I'm doing, it also takes a lot longer. But that's just how it goes. That's the reality of things. I always somewhat dislike those YouTube videos where they're like, "Oh yeah, I worked on this feature," and then they just show it for like 5 minutes how they typed a few lines, but in reality they probably worked a week on it. And it's just like a bit, it gives the false impression that people are like very fast in what they're doing. Um, I mean, there probably is some people that can churn out code within like a few hours and get it perfectly to work, but that usually comes with experience. So, and I don't think a lot of people can do that, honestly. But what do I know, right? It's just what I think. Anyways, let me go over to the screen. So as you can see, I opened up this website CPP reference as well, because they have quite a good C language reference in here. And I explain the reason for that in a second, because so they list all the header files that belong to the C runtime. That is fairly important, because the C runtime is actually the thing that makes C portable, right? So every C runtime implementation kind of tries to implement all these different header and the corresponding functionality, all the functions that they provide. And so far, the only thing I've been looking at is the the C runtime documentation for Windows. Now, nothing wrong with that, because I'm programming on Windows. But I noticed they have a lot of functions and extra stuff in there that is not exactly portable. It's Windows only, which is what I was not aware of. So on things like when we go to things like these, like the GameBoy header that I wrote, which is supposed to be a header file that you can, put in any other projects that you want to use and just start passing out header files. And it should probably work on other platforms as well. Which means I need to make sure that I'm not using anything that is just, Windows only. Or at least if it is Windows only, mark it within if-def of like, hey, if someone is using Windows, use that function instead. As opposed to like, I don't know, the standard one. Because that is what Windows recommends doing, right? I don't think in this header I do that, but it's just something to be aware of. So this is why I have this one open, so I can look for the C standard implementation first, before I then go over to the Microsoft documentation and see like, okay, what is Microsoft actually recommending to do here. This is the site I actually wanted to go to. Hang on, I bookmarked the wrong one then. I want this one. No, it's this thing. Cool. And of course I also made some bookmarks now, so I don't lose all this stuff. Okay. What are we going to do? Where did we leave off? Right, we left off with the output path, especially with this problem. So if the path we added is not a file, but rather just a path, we wanted to simply attach output.cvs in there, but we found out that there's no easy way to actually check if something is a path or a directory. I thought maybe we could just search for the dot in the last path segment, but it turns out a directory can just have a dot in its name as well. Like, there's nothing stopping it from doing that, right? So I think the only feasible way is try to actually create or open the file, and if it fails, we know it's just the path, and then we retry. Okay, but that is besides the point. So what I'm doing is instead of actually attaching output.csv here, if the option flag is not set, all I'm doing is I will set options.output to the same as options.input. And then we deal with the whole output.csv later down in the chain, right? So let's say, actually, is there a Win32 API directory exists? Only in this weird API right there. When I say weird API, I mean this SHLW API, which is like the Windows shell stuff, and I don't want to import that library, obviously. What is all this nonsense? Why is everything just shouting at me today? Like, keep your pop-ups away. I hate what happened to programs. Like, they're so shouty all the goddamn time. Like, I remember back in the day as a team when you started a PC, it was, like, stuff was just quiet. You just had a desktop, nothing happened, right? You open the browser and there was browser. Now you open the browser and there's a new notification, there's an update notification, then there's something popping up down there, then Steam is coming up here, hey, whoa, we have some news for you, and then it's just like, stop it. Okay. I'm being a bit grumpy this morning. I think. So let me not rant in front of the camera. Okay, so let's just copy input to output. So we do wide character string copy. Hey, I have those names down now. And do we know that input is already sanitized? Let's see, what are we doing in input again? So if we have input, we do this numbered copy, which is the sanitized copy with the path length. So yeah, we're kind of already doing that. So we know whatever we have here is a valid, well, we don't know if it's valid, but we know that the length is correct and everything else. So we can just use WCS copy instead of WCSN copy, meaning that we don't need to specify a size for the of how long the input string is when we copy it. We just copy it until we reach the null termination, because we know there will be a valid null termination at this point. So, okay, we can do output. No. Options.output. The size in words, again, is max path. Right, and then we have options.input as the source. If this fails, hang on. Come on, yeah, it has Erno. So if this fails, then we can probably print CRT error, and we can say fails to set output path to the input path. Failed to set output path the same value as input path, and then we just print out the value. How about that? That's probably best. Options input. Cool. And because this is a no-no, we return with exit failure. Okay. Of course, this needs to be white string. Okay, so we can just remove all this, the to-dos. We do not care. We finally figured out a different way of doing this. Okay, so we have read command line options, which is in the options header that we have right here. Let's open this one up next to this. So this is our implementation right here, which is fine. Is max path still appropriate? I mean, we'll figure that out at some other time, I suppose. Okay. So, and then we have flags. I mean, the flags, we do not need to validate any of these up front, except maybe Win32 UI mode. So what we should probably do is saying if option, no, we have this macro, right? Options flag is set, and we have options, and the flag that we're trying to check is options flag GUI. So if the GUI flag is set, we obviously want to do something special here. We actually want to show a UI window, which in the first version I'm not going to do. At the moment this will be unsupported. So all we're doing here is we are writing wprintf, and what we're just going to say is GI mode is not supported yet. And we make it terminating. So in the future, what I would like to do is, I think we can actually add to do here, right? Implement UI mode. So what I would like to do in the UI mode, once this is starting up, you can still pass in input and output path as command line arguments, and it would set them as defaults, you know, for the application. Similar to some other of these flags, it would just set them as the default, but then it would still display UI, so you can change them. It's just basically one way of setting default values for UI, more or less. Except, of course, stdout. Stdout will no longer work in the UI mode because we're not in command line mode. Also, no file won't work in UI mode because you definitely want a file there. Because we're not going to implement like a table to show all this stuff. That would be nonsense. There's other programs that already do that, so why reinvent the wheel, right? So we're probably just going to have, whether it's recursive or not, whether we want a table header in the output or not. Does that make sense? Yes, because we could still append to a file. That is important. Yeah, so basically we're just going to have these three. That will also be valid for the UI mode. Okay. So we set input and output path. We actually print them out right here, right? Do we have any debug values set by any chance? I can't remember. Yes, so we set the output to this. Let's specify the input to something else as well. Just take this folder and we say input is this one and output is this one. So we have as input VS projects, test folder in all caps. Right, take these out and put them in, geez, test folder. There you go. So it's not going through all the, the files. My dog is barking again. So it's not going through all the files of our project, so we're not cluttering everything in our test. Let's just be straightforward. Okay, have that as input and output. Excellent. And now what we can do is we leave Tetris in the first folder to test recursive searching, and the other one we put in here. Let's just call it subfolder and put Super Mario Land 2 in there. So now later on when we test the different options of like whether it should be recursive or not, we can see do we get 2 ROMs or do we just get 1 ROM in the output. That's it. And actually as the output, let's not put it in the test folder, let's put it just in the projects folder, right? Just as a test. Why not? Cool. So now if we run debug real quick, let's go breakpoint here. You can see correct directory, test folder, even with the spaces it works just fine, and the output file is projects. Cool. We can probably get rid of these. We don't want to output that all the time. There's this Unix philosophy of like silence is golden, right? If your if your program is successfully running and what it's supposed to be doing, there shouldn't be any output, because you do not want to clutter the whole screen with like useless output, unless the user specifically specifies that they want that. The only thing that you should be reporting back is failures. Anyways, so we're trying to adhere to that philosophy a little bit. The quick output that I usually just have with like, showing the input and output folder just now is like for debug or testing purposes, things like that. Okay, I said that a dynamic buffer doesn't make much sense anymore, because ideally we just want to write directly to the file. Okay. I think we just start by creating the file, right? Create output file. I mean, that seems sensible to do right now because we want to open the file first. So let's see, how do we create a file? So we have wf open as, right? And actually, let me check the documentation on this one. Where is IO? There we go. And we have fopen and fopen s. Okay, W is not in here. Is it actually in? Okay, extended multi-byte and wide character utilities. Is it gonna be in here? I'm just checking all the other headers. Okay, it's probably gonna be in here, isn't it? Interesting. I think we found the first one that's actually Windows only. Yep. So there is no white version of this in the standard. Interesting. Okay, well, I should just use it anyways because we are just a Windows program after all. Okay, so we need a file. It's gonna be our output file, the output file handle, and we pass that in here. We need the address of output file. The file name is specified here, right? Output. And the mode, well, the mode depends on our flags now. So usually we just want write, open the file for writing, or we want to append to it. So actually a file already exists, right? So if we have W, it will say destroy the contents, or just create a new one if it doesn't exist. Otherwise, with append, you write to the end of the file, or you create a new one, right? So this is where we need our flags. So what we can do here is, this is a wide character as well. So let's say, what do we call this? Mode. Fine. And the mode is dependent on our options flag. So options flag is set. And the flag we're trying to check is options flag append. So if append is set, we are doing an A, right? Correct. And if it is not set, we're doing a W. Then we can pass in mode. And so this is the important bit now, because output file can just be a directory, not necessarily a file name. And if that is the case, we do not want to add, if this is the case, we do want to add a default file name for it. So this open should fail. And if it fails, we're just trying to attach the file name to the output path and then try to open it again, right? So let's say output is potentially just a directory. So add a file name to it. And we can do this with our append path function that we created before. And what we have is options output, and we are appending what? Can't type. Output CSV. If this fails, we're just going to print an error later on, but we're not going to bother about this now because the copy should probably just work. I should just write it out now. Sorry. Actually, append path already will report the errors. If we look into it, it already has print CRT error in there, so we can just return and fully give up. Return exit failure. Right? And now we're basically just trying again. So if wf opens and again into the output file, options the output, the mode again, the same one. So, and if this doesn't work, then truly something fishy is going on. So we just say print CRT error, right, which will print out the exact error of why it couldn't open the file. Failed to create slash open output file, and then we print the output file as well. Options dot output. There we go. Okay. And down here, we should have a valid file by now. So I have a breakpoint down here, which is fine. So hopefully that will just work out. Where's the solution? There we go. Just to showcase, so we have an input folder with test folder, and we have specified an output folder, which is projects, right? So what should happen now? If we start debug, it fails to build. That's a good start. All right, this needs to be a white character message. Okay. File redefinition. Oh, because I have it down here as well. Yeah, we need to get rid of this eventually. Actually, let's get rid of it now. Yeah, okay, cool. Okay, we got to this point. And seems output file has been created, and we indeed have attached an output.csv on there, so we can actually check. Indeed, here it is, output.csv, and this is our test input folder. Okay, let's see what if this would go wrong, right? Let's say what happens if we want to put the output file in a folder that doesn't exist, right? So output, what happens? Whoop, left my alarms on, it seems. It creates a file called output, which technically is correct, right? Because file names do not have to have extensions, so this was a brain fart on my end. Let's remove it. Output and then a slash set. Okay. What? Oh, did I fuck up? Possibly fucked up. No, I did. Okay, let's remove the quotation marks then. Ah. Okay. So we are actually doing the right thing. Output.csv will be attached to it, but we're not creating the output folder. Okay, creates a new directory if the oh no, error path not found. One or more intermediate directories do not exist. So if we have like multiple output directories that do not exist, it won't create them all at once automatically. Why? But it is create directory X, right? Well, there it is again, the Windows shell, which does have a function like that. Oh, how I hate this. I really do not want to include Windows shell. I really, really do not want to. Okay, well, it is what it is for now. I'm not going to bother too much with it. If it doesn't exist, it doesn't exist. I can probably add this as a to-do for later on. In fact, let me do that. Actually, I do not need these to-dos anymore. Okay, so for potential future updates, right, allow output directory to be created if it doesn't exist. Implement Win32 UI mode. That will be the to-dos. What am I doing? Nope. Okay. So that is fine. We're just not gonna bother with that. Cool. So now that we open the file, we can start writing things into it. Although, so there's also the no file specifier, right? Let's think about how this would work. So appending to an existing file exists, right? We have done that here with the options flag. But now we have stdout enabled or no file enabled. So a file will always be created. And if we specify stdout, we also want to not only write to the file, but also to the standard output, so it can be used for piping. But you can have both, right? You can still write to the file or to stdout. However, if no file is specified, we actually do not want to set an output file at all. So probably what we should do then is have this up here. Because even if we are here, no, that doesn't make much sense, does it? No, it does not. Okay, let me think about this. I know those two flags are kind of confusing. I'm not too happy about it, but yeah, okay. So if we are not in okay, sorry. I'm just trying to figure out how this would work further down the line with what we already have with the read-ROM headers, how I would choose which streams to output to. What we could do is set it to null by default. And then if options flag is set, and the options flag is options flag no file, sorry, is unset, then we just simply do not bother with creating the output file, right? I think now we can go back to actually writing the output stuff. Okay, first of all, let's remove all these dynamic buffer nonsense, right? Because that was a really, really bad idea. We're not gonna need this. This was me overcomplicating a lot of things. Goodbye. This is one major lesson here as well. Don't be afraid to delete code that you have already written. Chances are, next time you're gonna need it, you know how to write it better anyways, because you already know the mistakes you made in the first time. And if you really don't need it, just delete it. Don't try to hang on to it. Unless it's obviously, like months of work, then maybe stash it away somewhere. But otherwise, just chug it away. I kind of want to put these print error messages out as well, but because this is a bit too cluttered for me. But anyways, let's just follow this through. So we have this read ROM headers down here. Read ROM headers is a recursive function which is fine and previously passed in the dynamic buffer, which we no longer do. Instead, what we have is we have an output file. So one option to do this would be we pass in the file, right, the output file, and then we also pass in our options. And then every time we're iterating through here, we could check whether a specific flag is set for, so every time we try to write to the file, we have to check, is the file null, right? If it is null, we're not going to write to the file, and then we're trying to check if stdout is enabled. But I don't like that. So I try, like, minimizing all the ifs on every call would be preferable, because we have potentially a lot of write to file calls, right? Could also get really fancy by passing in function pointers and like building different functions depending on what you're doing, but I'm not sure if that's better or not. Maybe I should just not worry about those ifs. And I just realized, if we do not have stdout enabled and we also have files disabled, then what exactly is our program doing? Nothing, right? So we should probably print out a warning that this is an invalid configuration. So, okay, let's do that first. So if options flag is set, and the options flag is no file, and let's not do it with an and, because now I can go into the else case for the file stuff. Right. And let's copy this to do up here. If options flag is set, then now we also want to check if options flag is set. Options flag. So we have the options flag stdout, right. So if all of these flags, if both of these flags are set, that's kind of an invalid configuration, right? So in this case, let's just print an error. sorry, is unset. Oh dear. If no file is set, but we have not specified std out, then our program is not doing anything. So, error, no file. No file is set without std out. Did you need to do that? No, that's condescending, right? That's not. No file is set without std out. Yeah, let's do it this way. No file is set without std out, which means this program would generate no output. I mean, we could be sneaky. Would it be better if I just set std out on default if no file is specified and you haven't set std out? I think that's probably nicer, right? Yeah. Let's do that. We say set option flag if unset. Or we just set it actually, whatever. Yeah, let's not even bother checking whether it's set or not. Let's just set it. So options, flags, and we're ORing in options flag std out. This way it just becomes an implementation detail. If you set no file, you just get the output on the console. And if you do not specify no file, but you also specify std out, you get both. That makes more sense. It's probably also less confusing. I hope. So, but then if no file is specified, but we also specified append, doesn't make much sense, right? So if options flag is set, options flag append, let's just print out a warning, because that's not technically a failure, right? It's just a bit, hey, it's a bit sort of superfluous that you set this one. It doesn't make sense. So warning. So if we have no file set and we also have a pen set, oh no, we shouldn't do exit failure. What am I doing? Just want to report a warning, that's it. Okay. This means we sort of have stdout enabled as well. Read ROM headers. So instead of passing in the whole options, we pass in the input path, we pass in the output file, which can be null, and then we should probably just have a Boolean flag that says whether stdout is enabled or not. Although no, because we do have recursive and headless, which we need to think about. Although headless can be dealt with right now because we're writing the file header before we even go into read ROM headers, right? So let's do that. So options flag is unset, headless. That means we want a header. So we're gonna write that one out. Probably don't need that char anymore, but let's see. And then we have if options flag is set, stdout. Let's print it out first. I mean, it is really just that, isn't it? We have file name, we have title, we have game code, maker. Let's just say title, code, maker, color GB support, super GB support. We have the pack type, ROM size, in kib, and ROM size in kib, the destination, and the version. Okay. So let's make this wchart. No. It should be a normal char. I think I just need a normal printf here, and then we do table header like this. Okay, so this will be writing it out into stdout if we have that flag specified. Otherwise, we want to write directly into the file. But file could be null. So if file, if output file, then we have, should I just do fwrite? No, fprint, right? Fprint s, or just fprintf? Is fprintf s actually standard C, or is that a Microsoft thing again? Let's check. It is actually standard C. Okay. So output file, and then just table header. And we have to do these two different ifs because, like, we could output into both, or we just use one of them, whatever. Okay. Now we can finally go to read ROM headers. Okay. Even though I pass in the options here, I want the input path to be separate because this is being called recursively as we iterate through the whole directory. Which is, so we have this little input buffer here where we just, you know, increase the file name depending on which folder we're actually in. So that's useful to pass it in separately. Do I need to pass in the whole options thing? No, I don't really need to, right? I just need the flags. So it's just the U8 flags. Done. Okay. So let's go through the code again to see if it actually all makes sense. So we have the combined path because we need to build up a search path for the find first file x function, which we do right here, where we then get our find data structure. We have an input buffer right here. Let's just call this input instead of input path, right? This is our search. We can give it a search path. And input buffer sounds a bit shit, so let's call it view path. Let's just call it file name, whatever. Because it is a file name that we're attaching to it, but it could still be just a directory, right? Do the arrows still make sense? No, not quite. I just realized that these wprintfs that I have done here should probably have just been f puts ws and then define std arrow as the output. Which print CRT error is already doing. Whoops, this one. Yep. I'm wondering if I can even mix printf with wprintf, because we are like in a wide character mode. Presumably it will just do the right thing, hopefully. Because for the file itself, I do not want to use wide characters. I just want it to be UTF-8 and it's just ASCII anyways. Fail to prepare search path. We should probably be a bit more descriptive here. So fprint f these names. One day I will learn them. I've just overwritten it. And I already forgot. Oh dear Lord. FW print F. Okay. Where were we? A. Oh, there it is. Okay, cool. std error. Fail to prepare search path for input path %s, and then we can just say input, because we want to see for which input path it actually failed to do it, right? Okay, find first file X, then we print the Windows arrow. Couldn't find first file in directory. Which directory? Yeah, exactly. We should be a bit more descriptive here. I guess search path. Yep. Then we combine the path. Fail to prepare input. Fail to prepare input file path. So fail to create path for input file %s in directory %s. So the input file would be in find data C file name, and the directory would just be input. That is a bit more of a descriptive error, right? So then we have a go to cleanup here, and why is that? Because we need to close the file handle. That is fine, and the result will be false. Okay, cool. So then we have the case where find data has file attribute of directory, which means this is a directory. We are ignoring the dot and dot dot directories, which this find data will always have. And then we call ourselves, right? And we call ourselves with the file name now, because that is the new directory we're actually going into. We have output, which is the file we are trying to write to, and we have the flags. And if this fails for some reason, we need to propagate the error as well. Might look a bit ugly, but I find this better than adding everything together with the ends, so I think this is alright. You might disagree with the coding style, but what are you going to do about it? Ha! Okay. File name. Right, this particular thing we should probably note down. If file name is the same as the executable file name, we are gonna ignore that one. This was for the particular case. You know, it's not just a command line tool. You can also just use the executable itself by just copying it into a folder where you want to use it and just double clicking it, and it already does the right thing. So there's no faffing about with the terminal if you're not familiar with that, or any command line options or anything like that. It just works, right? But we ran into this problem where if you pop the executable in the same folder as all your ROMs that you want to read all the header files out of, it will obviously go through, try and read the executable itself. I just bumped the mic, sorry. Try to read the executable itself, which obviously is wrong, so we're trying to ignore it. And now I just realized we probably should do the same with the output file as well. Because otherwise it's try to reading the output file, right? Which could be in the same folder. Whoops. Yeah. Oh, shoot. This is where we need the options, don't we? Okay, I give in. Options T, options. Let's just get the options in. Fine. Instead of passing flags, we pass the options, and then we have options output. And I bumped the mic again. Jesus. Let's format it like this. Okay. So now we're actually using the GB header file that I wrote in the previous stream. Well, we have this GB header struct, and we're going into the read GB header function, which we have down here. What we're doing there is we have, oh no, this is the, apologies, this is where the naming screwed me over. This is the read GB header down here. Oh god, I don't like this at all. Okay, ignore what I just said. Yeah, I don't know if I like to have this separate like this. I should at least rename it so it's not kind of the same name as the GB read header down here in the GB header.h. Okay, let's call this extract header from file. And we have the file name and then the header. Let's switch those around, kind of makes more sense in my head. And so the same thing, we have the ROM file. We're trying to open the ROM file with read binary. Um, so it either works or I don't know why I have this equals null here. I think that was on a previous stream where I just complained about something, that it could be null, but I didn't quite see why. Okay, let's leave this in. Then we have print CRT error, failed to open, well, it is a ROM file, so let's call it what it is. And then we have a 4 kilobyte buffer. We are trying to read all 4 kilobytes from the file. Why 4 kilobytes? Well, because that is the sector size of my hard drive, so it's more efficient to just read that all at once. Then we have, so if we fail to read less than 4 kilobytes, because the file is smaller or whatever, then we definitely know this can't be a Game Boy ROM, because the smallest Game Boy ROM, which is dictated by the Game Boy programming manual, right? The smallest chip the Game Boy can address is 32 kilobytes. So no matter what, a Game Boy ROM will be at least 32 kilobytes. I mean, it would be nice to put it out as a warning. wprintf. wprintf, really? No. wprintf? Oh my god, okay. I will learn it soon. I will learn it soon, I promise. So we print it out to the error, and let's say okay, not able to read at least 4 kilobyte from file %s. This file is probably not a Game Boy ROM. And then we add the file name to it. Okay, then we go to cleanup where we close the ROM file. Then we call GB read header with the buffer where the header starts, buffer size minus header start. Yeah, we know this is all correct because we've used it before. Print CRT error, failed to read Game Boy header from file S. Yes. Let's call it GB ROM. I don't want to use the word Game Boy anywhere really in the text, just because I'm getting a bit paranoid with Nintendo always. Failed to read GB header from file. Yep. Okay. So extract header from file sounds nicer because this is what we're actually doing. Right, let's put this up here. And then we can rename this extract header from file. And the file is just going to be input. No, we call it file name, sorry. File name. And putting it into this header struct. Fantastic. At this point, we have a header where we actually do write header to output file and slash or std out. I'm just making it a to-do for now because I want to go through the rest to see, just to check if everything is correct, sort of do a code cleanup, right? And get this to compile. Okay, we have an error message down here. So if for some reason find next file failed, at the moment we print out fail to print all files, which doesn't make any sense whatsoever, right? Fail to fail to read all ROM files. From %s, it would be good to know, no, not file name, sorry, input. It would be good to know in which input part we were actually failing at, right? Because this is being called recursively. If recursive is enabled, which we need to do now. That's a good point. So, in this moment here, if find data has a file attribute directory. Let's put that in here. And options options flag is set. Option and the flag would be recursive. Why? Oh, I called it options. Really? Right, okay. To explanation what just happened. This options flag is set is a macro. And so a macro is not something that's being called, it's something that's being replaced by the compiler. So the compiler goes through, sees this macro, and what it does, it replaces this call to the macro with this code that you have written here. So it basically just takes this chunk, copy pastes it, and overwrites this right here, right? So we pass in an option, and I have this code here where I check the options flags, but as you can see, it is doing it with dot because it assumes that the options is just a struct that lives on your stack at this particular moment. But the options that I'm passing in here is a pointer. So what I need to do instead is dereferencing the pointer. So you have to imagine, okay, let's go through this. Let me put this here, just so I can explain this properly. So this macro call will be replaced with the following. Let's just put options in here, right? This macro call will be replaced with this code. So what happens is you have options.flags, and then this code appears like here in this end. But because options is a pointer, you need to dereference it. So it means you need to use the dereference operator. So you can use the dot instead of the little arrow. So whatever you pass in here will be passed down here. So it would be star options. But because the operator precedence means that dot is being called before the dereference operator, you have to, whatever you pass in here, put it in parentheses like this. So it will be used in parentheses like here. Does that make sense? So now you basically dereference the pointer, and then you can use dot instead. Actually, options flags with this arrow notation right here is just a shortcut to exactly this. Right? So these two things here are exactly the same. It's just a convenience operator, let's put it this way. So if we have a directory and options flag is set, we can just, so only then we will do recursive part, otherwise we just continue with this loop until we have no more files to go through. Okay. That all looks good. So now we have all these write methods here, which we will comment out for now, because they use the dynamic buffer, which we no longer have. Okay, we have recursive. Done this. So now read ROM headers with options input, and we need to pass in the output file and options. We no longer need this to do. Okay. Now, read ROM headers has changed. So we need to put the right definition up here so we know which one to use. Read GB header and print GB header are no longer a thing. Okay, I forgot to use the white character on all these error messages, so let's do that. Also on this one. Oops. Then we have append path and combine path, and we're still using those quite extensively, right? And these print arrows. So we need those definitions up here still. We have buffer size for kib. Oops. We don't need this definition all the way up here to clutter the stuff, right? We're only using it down here, really. Wait, here. So let's call it read ROM buffer size instead. Okay, cool. Okay, read ROM headers we have up here. Okay, this looks much cleaner now. I like this. But there's still these squiggly lines down here which said read ROM headers are not found. So I'm not exactly sure why. Let's compile this. Rebuild all succeeded, so maybe it's one of the other error messages. What do we have here? Printf. Oh, really? You complain about this? Sure, let's call it puts. Hang on, does... does puts attach a new line? I think it does, but let's make sure. Puts. The puts function appends the new line character to the output, while fputs does not. Okay, then we're going to be cheeky and using fputs, and as the file stream we're just using stdout, which is basically what puts is doing anyways. You know, just being cheeky here. So this doesn't need to be fprintfs anyways, because we do not have arguments anyways. So really, this can be fputs as well. But we need to rearrange these. I'm really annoyed by these squiggly lines. Okay, so this is fun. Those squiggly lines give a suggestion of how to fix it. And if you say copy signature of ROM headers to clipboard, right, and then just copy paste them in here. Whoop, come on, you just did it. Show potential fixes, copy to clipboard. There, you can see it's still trying to get the one with the dynamic buffer, which no longer exists. I mean, what? We just rewrote it? Why is it still thinking this is a thing? So this is Visual Studio just being stuck in some weird state. Super annoying. Oh well, can't be helped. Right, so we rebuilt that. The only thing that we now need to do is doing all of these things here, which I just commented out, because this was using the old dynamic buffer, which is no longer a thing for us. We just want to write directly to the file stream or the output stream. And we need to attach this to this thing right here. So we have a header struct, and all we now want to do is write out this GB header into a file stream. So let's just create a new function for this. Does this need some kind of return? I mean, that's the thing. If you want to be super pedantic about all this stuff, right? Every fprint or fputs that you have where you actually write things could in theory fail. And I should probably check the ones that are writing into the file stream. So this one. And this one. I don't know if it's ever possible for them to fail, but you know, they do return an error code, so technically. So, but that answers my question. Yes, we do want a return here, right? So what we want is a bool. And what we have is, let's call this write header to file. and we have a wchart file name for the file that we want to write to. No, we do not. We have a file handle we want to use instead, and we have a GB header. Now, in this moment, it would make sense to pass in the options. We could just have a Boolean flag here. Let's just copy the flags, it's easier. We already have them flying around, right? And we have macros for it. Okay. And one thing we did previously was we had this this function right here where we write a CSV value. And the reason why we had this is because if there in the Game Boy title and in the game code and anything that can be represented by ASCII within the Game Boy ROM, if there's a quotation mark, we need to double quote it. That's just one of the rules of CSV files. And also as a precaution, what I did is I was surrounding everything that I wrote in there as a value with quotation marks in general. That is because a comma is also a valid ASCII character for a Game Boy title, and if you have a comma in an unquoted field, it just counts as a separate value, so it would kind of screw up our table in the end. So that's why it's just safer to just quote everything. So yes, we can use this one, but it probably will end up a bit smaller. So let's do bool. Let's just call it write value. We have a value right here. Why do we have the size? That is a good question. Let me just check my code real quick. I think I made sure that they're all null terminated. So I don't think I need to pass in the size at all. Let's just remove the size. Let's specifically mark this as inline because this will be quite small. And now what we can just do is, if actually, basically what we need to do is just this thing right here, right? So if, why is this marked as red? Oh, cannot use the macro, can we? Anyways, so if flags, and we check for the std out flag, right? If std out is specified, we just can do fprintf. The file stream will be std out, and then the format, we can do the 2 quotation marks, right? And then our value in between will be just %s. No, it can't just be %s because we need to double quote stuff. Okay, fine. Okay, let's do it without the flags for now. And get this done without flags, because I can just call it twice, then that's fine. Okay, so f puts into output. So we write a quotation mark, Jesus, into output. Yep. Right. And then we can say while how do we do this? Char character while character equals value plus plus switch character. So if this is a quote, then we need to double quote it, which means we put in f puts 2 quotation marks into output. Otherwise, we just write the value character. Say f put c. Okay. So this is how we write a value. And then because for the file stream we can specify our output file or standard output, we can simply call this twice for every value that we write. Let's see. Maybe we can do this as a macro. Actually write this as code first, because then it's easier to write a macro out of it, because then I just need to do some formatting. Because writing macros from the get-go is a bit of a pain, especially if they're multi-line macros. Like single-line macros like this, okay, whatever, works just fine. So let's assume we want to write a specific value, right? We have a value, whatever that might be, and we want to write that into the file. What we would do is we would say write value, and we will put that into the file. And then before that, copy this one. Well, sort of. Okay, flags. So flags and flags equals this one. So the std out flag is enabled. Then we would call write value with the value to write and std out as the file. Then if file, then we would say write value with the file. There we go. So and because I do not want to make a function call for this, let's just do a macro. Right. Define write. Did I call it write CSV? Let's call it write value with flags, whatever. And what we need to specify is the value. We have the file and the flags. Okay. Now, okay, this is going to be fun. To have multi-line macros, what you need to do is every line needs to end with this slash, right? This denotes like, oh, the macros is going over multiple lines. So this would be a 4-line macro, right? To make the formatting easier, what we could do here is put a do and then a while 0 in here. Well, it's not just for formatting. This is also useful if you want to, how do I explain this? Macros can be used in if statements as well. And so you don't have to deal with like, you know, all the braces and everything to make that kind of work in any if statement to return the right thing. What you can do is just make a do while with 0. So we just go through it once and the compiler then optimizes it out. It's just basically a way to trick the C compiler to make your multiple line macro work in like if statements and all this kind of stuff. You can probably Google a much better explanation than I can give for this. Okay, and we can just copy the code in here. Okay. And what we now do is just do this. And there we go. This is our macro. I mean, it also makes it easier to use like semicolons and stuff like that because it is within the do while loop, right? Otherwise, you would have trouble writing that as a macro. It's kind of usually don't write semicolons into the macros, specifically because you can use it in if statements as well. And okay, so flags is this. Write value is value. Write to std out. File is file. Yeah, cool. And now every time we call this, it gets replaced with the code above here, which is exactly what we want to do. We kind of actually, now we're kind of interleaving writing into a file and then writing into std out. Which, now that I think about it, is probably not the best way to go on about this. We should probably write the complete header instead. Yeah, see, this is one of those instances. If I just thought about it for a little bit longer, I could have avoided writing all this. Okay. Well, you learned how to write macros, multi-line macros. That's something, I guess. So instead, what we're going to do, write header to file. We're just going to call this twice down here with the flags that we need, right? So let's write first to the file, which is called output, and then we have the header as address. Right, and then now we can check for the flag, and then we can actually use the options flag macro that we have. Options flag is set. Again, we need to dereference options flag std out. Then we can copy this, and instead of output, we write to std out. And actually, we can also ignore writing this altogether if we do this. One thing, if you're not familiar to C, this kind of caught me off guard as well, because I was like, oh, but if you're doing multiple calls to writes like this, won't that be inefficient as opposed to, like, you know, writing everything in memory and just dumping it all at once into the file? And that's exactly what these file streams are doing. So all these writes to files are actually buffered, and they're buffered to the right sector size, so probably in this case 4 kilobytes. So whenever you call all the writes, it will just put everything into buffer and then just flush the buffer at some point and write to the actual hard drive. Okay, and now we can just try and make this code work, where we put the actual values finally into the file. Okay. Bam. So every write CSV would be with write value. First, we write the header title. Oh, and I just realized we need to write the file name. Okay, probably the easiest if we just say write header to file, file, header, yeah. Because the first section of our table is the actual file name. And I remember this is where my annoyance started, because I had a white char function for these write values as well, because, well, file name is wchrt, right? But I think what I'm doing instead now is I'll try and see if there is a function can convert it back to a single char version. So WCS to MBS. Our destination will be some sort of buffer, right, which is this. The source is the file name, and the maximum count is probably max path. Although, so a multi-bytes would be UTF-16, right? So let's just make it max path times 2. See what happens. Okay. What's the return value? On success, returns the number of bytes, but excluding the terminating thingy-majingy. Okay, so file name size. On conversion error, if invalid white character was encountered, returns size t -1. Are you kidding me? I think size t -1 is just a fancy way of saying max size, right? Let's make a breakpoint here. Wait, what? This function is unsafe. Fine. Use the safe version then. And of course it has a different signature, because why wouldn't it have? What is Redwell? What? Pointed to a size t object where the result will be stored. Okay, fine. Size t, file name size. If this is not null, and something went horribly wrong, that to-do should probably be up there. Let's just do return false for now. To do print some error that makes sense. Cool. And we need to pass in the pointer to the file name size. Could set it to null. Let's see. Return 0 on success. Okay. In case of a runtime constraint violation, stores size t -1 in Redwall, unless Redwall is null. Runtime constraint violation. Does that mean a conversion error? Because you're not talking about conversion errors here, even though you're talking about conversion errors up there. Oh, dear Lord. Writing documentation is hard, I get it. Too few arguments. File name size. Destination. Destination size in bytes. Fine. Have them. I'm okay with it. Do what you must. Cool. Well, we successfully converted file name bytes because, hey, guess what? It's all ASCII. I don't have any Unicode characters in my on my hard drive, which I should probably do at some point to test all this, but it's fine like this right now. Okay, so file name size. Okay, what I wanted to check is what the hell is size t minus 1, right? Size t. Right. Yeah, that's just max value, isn't it? It's a -1 cast to size t, and size t is unsigned, so yeah, of course, it will just be max value. Okay, so if this is not null, or file name size equals size max. It's exactly the same as -1. Could have really just written max. Whatever. I'm continuing to be grumpy, which is not good. But we're almost done, so let's just knock this out of the park and then can call it a day with this tool, I hope. So file name size, file name bytes, yeah, we saw that worked. Let's just keep it by path2, this is fine. Convert file name from multi-byte to, from byte chart to multi-byte chart. So we need to convert the file name, and then we can start writing the file name with right value, which just will be file name bytes. And we're writing that just to file. Cool. I probably should also check for errors over here. That's why I have a bool in there, right? F put S. Return EOF. Cool. Oh, good thing I checked because I forgot all the breaks in the switch statement. Not great. not bothering with printing out stuff right here. We're just going to delegate that up to the caller, and we also won't do it here. Okay, now finally, let's do it. Let's now we can finally start writing the actual information we wanted to. So we have the header title. Yep, which we're gonna write to the file. Then we can just say if honestly, I wonder how worthwhile that is to actually worry about all these error checks. You know what? Screw it. I just don't want to pollute my whole code just with just for the possibility that writing to an open file stream could go wrong. I mean, you'll probably notice if that happens anyways. At least I would hope so. Whoops. Where am I? Right. We can probably just check kernel at the end of all this anyways. See if the error number was set somehow. Yeah. I mean, here I do want to check. False. But for all of these calls, we're just going to do an error check at the end to see if something went wrong. So fputs and what we fput c, and what we want to put is a comma, because it's comma separated values after all. Right. After the header title, we have the code. Let's just do this everywhere where we have a comma. Just gonna replace it with this. Okay. Then we have the maker. Then we fetch out the color support. Then the Super Game Boy mode. Yep. Then the pack type. And that is my coffee alarm. My pack type. Yep. The ROM size. Correct, but this time what we're doing is we remove all the kibs here at the end and mib, and this is 0.8. Because we specified in the table header what our unit is. And the reason for that is because I noticed when I try to sort based on the size, that would just confuse things, because then it would also, like, it just didn't work out. It's much easier if it's like recognized as a number, and then you can actually properly sort out the number. Your mileage may vary with whatever tool you use to open CSV files. So RAM size none, we just make 0 for no RAM. And unknown is fine. Okay, and then we have this into the file as well. Then we have the destination, correct. And then we have a number, which we can now simplify as well. The version. The version itself now, it's just a byte number, right? And it doesn't need quotation marks necessarily. And if it does, what we can do is we can say fputc quotation mark. Then we can say fprintf percent %d, sorry, in the file stream file %d and header version. And then fputc yep. And do we need a comma in the end? No. Actually, what am I doing here? I'm using fprintf. I can just combine all of this, right? I don't even need to do the extra calls. What we need in the end is a new line. There we go. This just became one line. Much nicer. Okay. Actually, here I can say fputc as well. fputS is correct. fputc and fputc as well. So, in fact, you're wondering, some implementations even just when you call fputS or even fprintf or anything of the sorts, all it boils down to is it will go through character by character through the string anyways, and then call fputc. So fputS with this string would just make 2 calls to fputc. Fputc might probably be inlined anyways, because it might be quite small if it's just writing to the buffer and then occasionally flushing, but I don't know that. I'm sure there's a way to look in the implementation somehow, but let's not waste time on that. We're trying to finish a tool here, which I think we sort of have done. Except here in the end, what we now want to do is check for errors, right? So first, what we probably want to do is p error print crt error Okay, failed to convert file name %s to a multi-byte representation of file name. But all of these, if they potentially fail, what do we want to do? So there is Erno right here, where you can check the error status, but I think we can also check on the file itself, on the file stream, sorry. I'm not quite sure how. stdio. CF error. Yes. So if we just call this on file, and we can just say print crt error, fail to write header to the output file. I don't have the file name for the output file, but that's okay. I think this will be a very rare occurrence anyways. He says, famous last words. Return false. So then down here, if any of these fails, well, we kind of already handled errors in there. So we can actually get rid of that. So like this. Should we stop if there's an error? That's the question, isn't it? Should I fail or should I just continue? I mean, no, since these are output errors, yeah, we should probably give up. Go to cleanup. Because like if there's something going wrong while writing this file, it will probably go wrong for the other files as well. So we're just gonna give up let it be. And then here on recursive, if it fails, we equally want to fail, right? So go to clean up, actually, not return. Yes. I think this is it. I think we might actually be done. Well, you know, apart from all the other errors that are popping up. Ah, no, I still have to do this here. Okay. I mean, here I can probably just do a separate check. Why not? That doesn't matter. Print a CRT error. Fail to write to output file %s, and that is options output, and then return exit failure. And then here, whoops, fail to write to output to std out, which probably won't happen. Okay. Let's just make sure. Okay, this is one to do for the creation. That is fine. We do not care for this version about it. This is good. This is good. Combine path. I don't like that I prefaced everything with an error, because if you have an output, it is an error. It will be outputted as std on std error anyways, which is the error stream. So let's remove these error things. Warning we can leave in as such. Okay, those were all error instances. I'm too afraid to compile it. run it. Seems too good to be true now, that it's just working. Oh, it even compiled without any errors. Oh, okay. We still have one problem here. I see, yeah, we didn't make these white characters. Fine. Those are unreferenced parameters, which is correct. I mean, after all, we're not using them. So probably what we can do here is just use winMain void. Because our read command line options are using the global variables right here for these things. So I still have error set here. Okay. That's just me changing my mind about like style of error messages and how they're supposed to look like, and happens a lot. I often change my mind mid-project. Okay. GB Header, as far as I know, doesn't print any error messages. Okay. So we have options.h. When did we create this file? I think yesterday, right? Probably. Okay, and then we have this. Okay, what other warnings do we have? Char differs from, yeah, that is correct, because we need to dereference it. Good catch. Compiler will insert spectre mitigation for memory load if QSpectre switch is applied. Well, thank you for that information, but I do not give a shit. We're not trying to be super secure server software here. Why should I care? It's like a nothing burger, really. Okay, let's try and compile in release mode. GB Header Reader. unreferenced formal parameter. Right, because asserts are for debug only, right? Okay, let's disable that warning because that is in release mode. Why would you care? I can never find the right. Where are we? Advanced. There we go. 4100. What are you doing? Why is it still here? Because I disabled it in debug. Should be released. What? Is this not how you add multiple ones? Okay, how do you do this then? Edit. Oh, semicolon. Fine. Fine, you have your semicolon there, why not? Assignment within conditional expression. Who cares? Jesus. Yep. Whoops. FWPrintF, function not inlined. And I do care why. Man, you're really chatty compiler. 4710. Function combine path selected for automatic inline expansion. Good for you. But why is this a warning? If it's for like some diagnostic purposes, has better ways of doing this? Or there should be better way of doing this instead of reporting this as a warning. Okay, rebut all succeeded. Right. It's too good to be true. So I want to add some. Okay, I should probably test this out now, shouldn't I? Before I like. Okay, so VS projects. Let's go in here. Copy as path. Right. So this is our executable path. We're gonna run this one, and we are gonna reference the test folder. So, and our output will be going in here. Okay. So we need this. As the input, we are gonna specify test folder. Like so. And then as the output, we are gonna specify projects. And let's do not recursive for now. Actually, let's copy this whole thing because I don't want to type it out all the time. Right. Okay. Permission denied. Okay, I think I know what's happening. Ignoring these directories no longer works because we had the options flag of recursive in here, which is the wrong position to do this. So we find out whether it is a directory, and if it is neither one of these, and options flag recursive is set. Actually, because we can short circuit this, we should probably put it here. Okay, rebuild. There we go. So now what we should see is an output CSV. Actually, let's delete this. This might be from the previous run. There we go. What the hell is going on here? So the file name works. Everything else seems to... No, it's kind of all shifted a little bit, isn't it? You probably forgot a comma. So let's see. Write header to file. Indeed, we do not have a comma after we write the file name. Okay. There we go. So we have the test folder, we have the Tetris ROM, we have the Tetris title, maker, yep, pack type, ROM only. We still have the ROM size, RAM size is 0. Destination Japan, version 1. And as you can see, Super Mario is not included because it is in a subfolder, right? For that to work, we need to specify minus recursive. And we get permission denied. Is it because the file is open? It indeed is. Cool. Excellent. I'm so happy about this. So, now the other thing we could try out is if we have recursive and headless, we should be writing out without a header. And indeed, as you can see, there is no table header anymore. So, what if we do std out? We should see both of it. We should see the file being created and stuff being printed out onto the terminal. And indeed it is. Right? Yes, and there are multiple lines as well. Fantastic. And this works as well. Okay. What else? If we have no file, it should just print out to the terminal, because that's what we specified. If we specifically have no file and std out, that just works fine as well. What other values were there to test? I forgot. So we have hablet. Oh, we have append. Right, append. Okay. Let's do append. Right. So we have recursive, and let's do with the header. Okay. There's 2 entries in there with a header. And now what we can try to do is do recursive, do append, and be headless. And then we can run this a few times. And then check our output. And indeed, we only have one header, and then it just appends all the other stuff onto the same file. Sweet. For the fun of it, we can now say GUI, and it will just say GUI mode is not supported yet. We are actually done. Well, apart from those 2 to-dos here, you know. Allow output directory to create it if it doesn't exist, and implement Win32 UI mode. But those are like, you know, the only reason why I want to implement the Win32 GUI mode is because I want to learn GUI programming on Windows. Because eventually I want to make tools that use the UI, right? So I don't want to do XAML and all this kind of nonsense. I just want to learn basic Win32 GUI. And then at some later point, I will be using DirectX and some graphics API or even my own rendering to do those UIs anyways. So I'm not going to be using default Windows 1. And this with the allow output directory to be created if it doesn't exist, you know what? Screw that. Executive decision right now. We're not going to bother with that. Okay. That's it. Oh, one more thing. One more thing. One more thing. So if we now build this in release mode, which can now actually be distributed if I wanted to, which I probably will. I will probably put this up on my homepage as a download. If we go in here and actually check the release executable, there it is. If we now look at properties, what we see if we go into details, it's like very bare bones. Like there's no copyright, no product name, no product version, stuff like that. We kind of want this, right? So what we can do here is add resource, right? And we can attach a version resource to our project. So let's just do that. By the way, I'm going to delete these ROMs here from the project because they are no longer needed. So as you can see, it will create a new resource.h, which the .NET compiler will use to like add some information into our executable. I can specify here as a file version, and let's see, main.c. Let's just call it version 1.0. Why not? Because that's how we roll. Yeah, the GB header has a different versioning because that will be at some point part of a library. I just have to go through it one more time. And as you can see, I have this libraries project here where I have multiple libraries. The idea is I want to create different header files that I can use for different projects and just reuse some code instead of obviously rewriting it all the time. So I want to have at some point like a collection of useful things. For example, one of the useful things could be combining the path strings together, right? That should probably be living in like a separate header here. At the moment, I just have one header, which is the profiler. This is to see how, measure performance of certain things based on the RDT-SC value, which is quite interesting as well. But yeah. So where was I? Resource dot. No, what? Where's it gone? Oh, there's a different resource viewer. Of course there is. Let's drag it up here while you're over there. Version info. So this is right. The file version, the product version, yada yada yada. Subtype, I don't even know. This is an app. Abso-fucking-lutely. Yeah, this is probably. I don't know what VOS NT Windows 32 is, or VOS NT. Let's just leave it as a default, why not? And then here, copyright. I can say, yeah, why not? Like this. And then company name will just be, oh, actually, hang on. If I don't write this, will it just add it? File description. This is a tool to read out GB ROM header information. Product name, GB Header Extractor. No, it doesn't fill out the copyright, so we're just doing it ourselves. There we go. So now, if I compile this, and we check in the release mode right here, details, you can see now that information is properly inserted in here. Even a file description, so what is this tool actually doing, right? And the version number. Cool. So, and if I want to ship this product, I can now just ship this executable. This is program file definitions for debugging, so in case something goes wrong in the release executable, you can use this to kind of step through stuff, but you don't really need to ship it, but it's good to store it somewhere away, so for every specific version that you have all those different PDBs, so you can actually analyze some things if you need to, like some crash or something. But in any case, I can now just take this exe and just share it around. Should probably do it as a zip file though. There we go. Can rename it. I always have to look for the rename thing. I hate that so much that they change it. This is GB Header Extractor 1.00. Huzzah! We've done it! Actually completed the tool on stream. Quite happy about this. And I'm quite hungry right now. So, thank you very much for watching. I will be uploading all of this to YouTube as well, where all the recordings live. And that's it. Thank you. Bye.